Hello, welcome back to Chapter 1, Foundation for Functions. We're talking about parent functions from Section 1.9. So one really important skill about math is modeling real live situations. It goes into that, when are we ever going to use this? Well, in physics, in biology, in chemistry, in science, in economics, when we collect data, sometimes we recognize patterns. And if we want to describe that pattern with an algebraic function, then we want to find out what parent function it matches up with, and then also talk about what would be the transformations. And the transformation, whether there's a stretch or a translation or whatever, might actually tell something about the data. These are things that you're going to be learning throughout while you're still in math class. There's a term for it. If I collect data and I match up if I draw what we call a scatter plot, and we match up two sets of data, if they do kind of form one of these patterns, finding the graph that describes that, finding the function that describes that, is called regression. And you probably are already familiar with linear regression because you probably did scatter plots and tried to draw a trend line. That's it. The thing is that not everything's a line. So sometimes you can draw it with, you can describe it with a quadratic or a different function. So that'll be a big idea as we go through this year, and as honestly, you'll be, if you just write down what I just said and put it in your notes someplace, all the way while you're doing math in high school and college, you'll be seeing this over and over again. It's kind of a big idea, describing data in the real world with algebraic functions. So we're just going to introduce this real quick to kind of see what we're doing. Now, there's two things. It says graph the data from the table. So straight up, if you just want to draw an XY coordinate and sketch the data, that's fine. Grab a ruler. Here's my drafting ruler that I have. So there you go. It's a little big for our purposes right here, but you can grab a ruler. You can even grab some graph paper. It's super. That's fine, no problem. But it's also okay if you do this. So what I did was this plus sign right here. I hit that and hit it again. And then one of the options is you can make a table. So I selected table, and then I'll hide that because I don't want to make another table. And then I just put in the numbers. So again, I've got -4, 8, -2, 2, 0, 2, 2, 2, 4, 8. So that's what I put into my Desmos, -4, 8, -2, 2. You can see them. And it makes this shape. So now the thing is, okay, do any of the graphs of the parent functions that we've looked at so far seem to go in that direction? So what do we know so far? All right, so I'm going to pull up this from the previous video. All right, and I know, hopefully you can see it. So it's not a constant or linear. Remember what I said earlier, constant function, constant family, those are actually linear. Linear means that it's a line, no bending. Well, it looks like if I'm going to try to draw something through those red points, it's going to bend. So it's not a line. Hold on. Cubic starts off down here, does bend, but then kind of goes in the same direction. And the square root does this curve, but it kind of curves off this way, and there's only half of it. I don't see that with either one of those. I don't see either one of those with what I got. What I think it looks like is this one, where it kind of comes from the top left, comes down, turns direction, and goes back up. So let me see if maybe this is my quadratic. Where'd that go? It's not letting me, come on. I hate it when the thing pops up. Okay. All right. Okay, cool. So it looks like the same shape as that quadratic. And I'm sorry, everything's red. I didn't notice that. Let's see if I can, come on. I don't want to copy anything. It's always hard to grab the right thing. There it is. Okay, I'll go to blue. Okay, so I've got that blue quadratic graph. So So I think that the parent function is going to be f of x equals x squared. All right. And I'll just sketch my graph right here. So I had this, 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 this. That means that the family, now notice like last time, it didn't ask for the family. I'm going to give it that too, since I'm in teacher mode, not just answer or do homework mode. The family is a quadratic. But let's try to see what actually happened here. How would I go from the blue graph to a graph that would go through the red points? Notice that at the origin, the vertex didn't change. That tells me that it's not a translation. So I can cross out translation, because if it was a translation, the whole thing would change, including the vertex. It would go up, down, left, right. But it looks like the red point and which seems to be the vertex of the red graph, and the vertex of the blue graph, the parent function, are in the same place. So that's good. We did talk about reflection. So if I reflected the blue graph over itself, that's not going to go through these red points from the new graph. So I've eliminated translations, I've eliminated reflections. What about stretches or compressions? Well, there's two ways I can do this, and this is because of the quadratic. So it looks like this point right there, I'll try to point to it, got pulled over this way to the right. And it looks like this point got pulled over that way. So everything is going, like if I grabbed it and pulled it that way, it's going to stretch out horizontally. So you could say it's a horizontal stretch. We'd have to figure out, well, what did you multiply this point right here by to get here? So that would be our scale factor. Also notice that, I'll see if I can get it right here, but it's not doing it. Okay, also notice that this point right here got moved down to here. And I know what quadratics are. This is x to the second power. So this is 1 to the second power is 1, and 2 to the second power is 4. Well, 2 to the second power equals 4, and then I found half of it. This right here, this is 4 to the second power, which is 16, and half of that is 8. So I think that I'm going to go with the vertical compression takes a while to write it, by 1/2. And if this is my g of x, I'm going to make my f of x. So here's my x, -4, -2, 0, 2, 4. Here's parent function, f of x equals x squared. So this would be positive 16, positive 4, still 0, positive 4, positive 16. So I just squared each of these numbers. And it looks like my g of x is going to be that divided by 2. So 16 divided by 2 is 8. 4 divided by 2 is 2. 0 divided by 2 is still 0. And then this is still 2, and this is still 8. And those match up with that. So I get an idea of it from the graph, and then I can actually just test that idea with arithmetic. Let's see if we can do the other one to still give you the idea. If I can grab the sheet, sorry. Okay. All right, so same idea. We have a table. Sorry, it's bunching up there. We have a table, and this is probably one of the parent functions we talk about. So let's see what we have. So let's hide this one for now, because it still might be quadratic. And let's hide this one. This is the graph that we just did. Now, notice I've got 5 points and only 3 of them are showing up. That's because -4, -12, and 412 are outside of my window. So I'm just going to pinch that down. Okay, looks good. Now it looks like I could lay a ruler like right along here. I'll grab this. I could like lay a ruler like right along there, and that's not a ruler, it's my tool that I'm using as a pointer. But everything seems to be like it's in a line. So I think this is going to be a linear function. Let's go up to the linear functions right here. Okay, so yeah, but it does not have the same slope. Well, if you remember from Algebra 1, the slope is what we call the vertical change over the horizontal change. I know, you probably heard rise over run. Please don't use the R words, okay? Because the words rise and run, it comes from construction, it comes from like pitch of a roof, which is really cute that we can make that connection, but it causes so much confusion for people who will say, well, what's negative rise? Or what do you mean by run? And I know we beat it into your head in Algebra 1, what it means, but we'll just say vertical change over horizontal change. Okay, well, this looks like it goes up 1, right 1, up 1, right 1. And that's true for the parent function, the slope is 1. But what about if I made a line that went through here? My slope would have to be a vertical change of 3 and a horizontal change of 1. Vertical change of 3, horizontal change of 1. So I think my slope is going to be 3. So let me try that. I'll say y. I mean, it would be g of x, but that's okay. Y equals 3x. And yeah, that's what worked. So let's go back to the paper for a second. The parent function is f of x equals x, and that comes from the linear family. And it looked like when I was testing it, looks like my function g of x equals 3x. Now, without the graph, maybe we can try arithmetic to figure this out. So again, I'm going back to this parent function, f of x equals x. So here's my x, -4, -2, 0, 2, 4. I'm just copying the table. Here's my f of x equals x. So that would just be the same numbers for my output. And now, how do I go from -4 to -12? How do I go from -2 to -6? What did I do every time? It looks like I multiply by 3. -4 times 3 is -12. -2 times 3 is -6. 2 times 3 is 6, and 4 times 3 is 12. And that matches up with this. So by multiplying it by 3, that means that I have a vertical stretch by 3. Each of the output values of the parent got multiplied by 3. And of course, that means I'm changing the y values, which are the output values. Okay, we'll see you in the next video.